So let's look at the fatty acids. Remember that lipids are composed of, simple lipids are composed of what? Fatty acids and what? And alcohol. Good. Now the fatty acid, they are mere carboxylic acid. And in chemistry, give me an example of carboxylic acid. Ethanoic acid, propanoic acid, butanoic acid, right? Good. So when we talk about fatty acids, we are talking about carboxylic acids that have the general formula ROCOOH. Where this arrow here represents the what? The alkyl chain, right? The alkyl chain. And this is the functional group, the carboxylic acid group. Now, this fatty acid here is considered as a derived lipid, right? Because it is gotten from the hydrolysis of simple lipids or compound lipids. So it is considered as a derived lipid. That's fatty acid. Now, we can classify fatty acids based on carbon atoms present, the total number of carbon atoms present, into even chain fatty acids and what? Odd chain fatty acids. Now, the even chain, you know, it contains even number of carbon atoms, right? Take for example, if you have something like this. Is this a fatty acid? Look at it very well. This is a fatty acid, right? Now this is the alkyl chain and this is the carboxylic acid functional group. Is this an even chain fatty acid or odd chain fatty acid? Even chain. Even chain. Check the number of carbons present. 1, 2, 3, 4. And 4 is an even number, right? So this is an even chain fatty acid. If the number of carbon present, like in this case, is this 3, right? Is this even chain or odd chain fatty acid? This odd chain fatty acid. So based on the number of carbon, the total number of carbon present, we can classify fatty acids into even chain and what? So all you have to do to identify that is scan the number of carbons present. If it is even number, even chain fatty acid. If it is odd number, it's what? Odd chain fatty acid. Do you understand that? Alright, so next let's look at classification of lipid based on what? Type of bonds present. So just listen up now. Based on the type of bonds present, in fatty acid, we can have saturated fatty acid. Please, I'll beg you to listen up here because this will form the backbone of other things we are going to be doing. We have saturated fatty acid and what? Unsaturated fatty acid. All right, I'll give you the notes. We have saturated fatty acid and unsaturated fatty acid. Now back to chemistry. When they said this compound is unsaturated, what does it mean? There is a presence of what? Either a double bond or a what? Or a triple bond, right? Good. But if they say a compound is saturated, it means single bonds throughout, right? So if you have this fatty acid here, we'll use the real names as we go on. Among A and B, which one is a saturated fatty acid? A. And B is what? Unsaturated. Because A contains single bonds throughout, so we said saturated fatty acid, right? While B contains a double bond here, so we said this one is an unsaturated fatty acid. Do you understand the literal meaning of it? So we are going to relate it to the topic at hand, and we treat it. So just know saturated, single bonds throughout, right? Unsaturated, we have a double bond somewhere. Good. Now talking about saturated fatty acids, remember that we said we classify fatty acids based on the type of bonds present into saturated and what? Unsaturated fatty acids, right? Good. Now let's look at some of the saturated fatty acids. These are their trivial names, systematic names, carbon skeleton and structure. The first one here is butyric acid, right? Now, any fatty acid, any saturated fatty acid that have carbon atom that is less than 10, we call it what? lower fatty acids, while those that have from more than 10, we call them what? Higher fatty acids. Now, butyric acid, the systematic name like the IUPAC nomenclature is what? N-butanoic acid, normal butanoic acid. We are not looking at the isomers, the normal butanoic acid. Now the carbon skeleton. Now this stuff here represents this 40 here. It's not man you playing against any like that. This first number you are seeing here is the number of carbon present, and this second number is the number of double bonds present. So here we have how many carbon? 4 carbon and no double bond, right? 0 double bond. That is why it is called saturated. So here there is no double bond. Now the structure is just your normal carboxylic acid, that you're doing your normal carboxylic acid. You agree with me that butanoic acid, that's butyric acid, has 4 carbon, right? So you can do your 4 carbon. Please listen up. This is it. But if you check very well, this and this, they are the same, right? CH2, CH2. So we can just write the CH2 in bracket and indicate that we have 2 of it instead of writing the long chain. So we can just indicate we have 2 of it. So that's butyric acid. Then the next one is caproic acid. First, is this one an even chain fatty acid or odd chain fatty acid? Even chain, right? Because you have 4 carbon atoms. So if you notice, everything here says they are even chains. Remember we said that even chain fatty acids are the most fatty acids found in the living cells, right? Found in lipids. Fatty acids found in lipids, most of them are even chain. Now, caproic acid. Caproic acid, the systematic name is what? Hexanoic acid, right? Hexanoic acid. Now let me give you hints. What is asked most times is from this lauric acid down. That's what is asked most times with these trivial names. These other ones, yes, you see butyric acid, caproic acid, but most times in exam they use the systematic name to represent these lower fatty acids. But it's good to know their trivial names too. But from the higher fatty acids, please take note of these, their trivial names. That's what they use to represent them. Now, caproic acid, that's hexanoic acid, have 6 carbon, right? And we know why this 4 is here. Is it not? Because we have 4 of this methylene group. Good. Now, caprylic acid, that's octanoic acid. 8 carbon, how many double bond? No double bond. Capric acid, lauric acid. So lauric acid is what? 12 carbon. Myristic acid is what? 14 carbon. Palmitic acid is what? 16 carbon. And you know, decanoic, deca is 10, right? Deca is 10. Dodeca, 12. Tetradeca, hexadeca, octadeca. 20 will be what? Alright, so if you notice, my camera is not reaching here. Now, stearic acid, octadeca, right? Arachidic acid, behenic acid, 22, and lignoceric acid, 24. Good. Now, okay, let's look at the unsaturated fatty acids. Now, recall that unsaturated fatty acids, they have 1 or more double bonds, right? In the carbon chain. 1 or more double bonds in the carbon chain. And let's look at some of them. Their trivial names, systematic names, and carbon skeleton. So after we've done this, we'll now see how we can draw them. Now, palmitoleic acid. Remember that palmitoleic acid have the saturated counterparts. When we're looking at saturated fatty acid, we have palmitic acid, right? And palmitic acid was how many carbon? Lord, my palm stares around Big Liberty. Lord, my palm. That's the third one, right? 12, 14, 16, right? So palmitic acid was 16 carbon. saturated. Now, palmitoleic acid, still 16 carbon, right? But now, there is now a double bond. Now, the systematic name is 9-hexadecinoic, not deca again, because now unsaturation is now here. Remember, double bond, we have the saturated compounds alkane, right? Unsaturated with double bond alkene, is it not? Triple bond alkyne. This one we have double bond, that is why here is not deca again but decinoic. So hexadecinoic acid. Now the double bond here, the double bond is on carbon what? Carbon 9, right? That is why in this carbon skeleton or the shorthand notation, so this is how this is, if they ask you to write the shorthand notation, this is what you use. Not when they say shorthand notation, now be thinking of, how many of you did shorthand in secondary school? Now be thinking of all those lines you used to know. This is what they mean. Now this shorthand notation here, the first one represents the number of carbon present. The second one represents the number of bond. And the third one represents the position where the double bond is. The number of double bond. So here we have 16 carbon. How many double bond? One double bond on carbon 9. That's what it means. So you can use this to 16 carbon, one double bond on carbon 9. Oleic acid. Please, you have to take note of these three because they all have the same number of carbons. How many? 18, right? Oleic acid, linoleic acid, and linolenic acid. Now, we have, based on the number of double bonds present, unsaturated fatty acids are further classified into monounsaturated fatty acids and what? Polyunsaturated fatty acid. Those ones that have just one double bond, they are monounsaturated, right? While those that have more than one double bond, they are what? Polyunsaturated. Now, oleic acid has how many double bond? The number of carbon is 18, right? How many double bond? On carbon. Linoleic acid. How many carbon do we have? 18. How many double bond now? On carbon 9 and 12. Linolenic acid, 18 carbon. How many double bond? 3. On carbon 9, 12, and 15. Now, among these three, which one is monounsaturated fatty acid? Oleic acid, right? Monounsaturated because it has just one double bond on carbon 9, right? And these two, they are polyunsaturated, right? Because they have more than one double bond. So, note that linoleic acid, 2 double bonds. Linolenic acid, how many? 3 double bonds. Good. Now, arachidonic acid. Remember when we're talking about the saturated, we have arachidic, right? But now, arachidonic acid. How many carbon? 18. Sorry, 20. Around. Lord, my palm says around. 12, 14, 16, 18, 20. So, 20. 4 double bonds on carbon 5, 8, 11, and 14. So if you are asked to write the shorthand notation, always use this 16. Let's say for palmitoleic acid, 16 carbon. How many double bond on carbon? This is called the shorthand notation. These ones are called the shorthand notations. So are we okay with this? Can we draw them now? So write this down. If you're not done, then let's see how we can draw them one after the other.